So here we are, Astronomy Cast, on time-ish.
Sorry for the delays. I was having all manner of computer chaos here.
Yeah. Hangouts are seeming surprisingly stable today. Last night it was crazy, but maybe we had like a lot of people. We had we had a full crowd last night. It was definitely a record on the virtual star party last night. We must have gone through 40 objects. It was
Wow.
like a mini Messier marathon. It was amazing. But it's like galaxy season, right? In the spring.
Yeah,
so
but
it was
you started at like 11 p.m. Central.
Yeah. Yes, about 9 Pacific. It's no problem. It's good. No, it's nice when we're in the wintertime and we start at 5 Pacific. That's a lot better.
Yeah, it was a little insane.
And if anyone has no idea what we're talking about, we do a virtual star party every Sunday night here on Google+. We hook up a bunch of telescopes to a live hangout and just share what we're seeing. So, no, it was great. We had, and Corey Schmitz sort of brought his new telescope setup, and it was just phenomenal. It was really,
awesome.
Yeah, I want his telescope. He's got a Vixen 80 millimeter refractor, and but with a really nice mount and huge wide field of view, and just phenomenal images he's pulling off of that.
Yeah, that's basically the scope I want. I just want the TeleView version of it, which is like bazillion times more expensive.
Right. Where you choose car or telescope.
Yeah. Hey, I drive a 1998 Jeep Wrangler. No one can say I spend too much money on cars.
92 Volvo here.
You live on an island.
That's true. So if anyone has no idea what this is, what they're watching, this is a live recording of Astronomy Cast, which is our weekly podcast about space and astronomy, and we do it as a live Google Plus hangout for some reason that we still haven't figured out. Practicing hanging out, I don't know. So you get to see it, warts and all, as we make all of our mistakes, and then it gets nicely edited for the actual podcast. So you get the sneak preview, I guess, is the point here. But you can ask questions, you can post comments, and we'll stick around after we do the show and answer your questions about space and astronomy. So by all means, stick around. So if you want, you can post a comment or question on the event page. You can, if you see it on my stream in Google+, you can post a comment there. If you want, you can use Twitter. Just use the hashtag AstronomyCast, or you could post a comment over on YouTube, where the video is being I guess, originated. Did you see Chris Hadfield's video yesterday? Oh, has Pamela crashed? No. She's crashed. Oh. Or have I crashed? Let's see. There's another Pamela.
It just like randomly redid the window.
Did you just refresh the window?
Yeah.
It's okay. I was entertaining the crowd.
Unexpected.
I was just mentioning Chris Hadfield's video.
Yes.
And you had something very poignant to say about that as it related to astronomy education and outreach.
Well, yeah, it was one of these things that while I was watching it, I realized this was something that had to have been planned in advance. This is something where he got help from Earth, and we actually had his son Evan left a comment, and there's a CDC radio interview that explains it more. So if you go to my Google Plus profile, you'll be able to find it. It's the most recent post. And looking at this right now with NASA, anything you do that isn't critical and predefined, that might be considered educational in nature, you have to get a waiver. And in general, anything that you want to get funding for, it has to be aligned with national educational standards. It has to be this, it has to be that. And so I don't think, given the current, this isn't a NASA problem, but this is rather given the problems related to sequestration, which have also grounded some of the military acrobat airplane teams and things like that, given the concerns of sequestration and the new White House budget that reorganizes education out of NASA and all of the other science agencies to rehome all the funding strictly at the Department of Ed and the Smithsonian and the National Science Foundation. NASA couldn't do this. Strictly, their hands are tied. And so if we had a
what about the
musically...
Canadian Space Agency?
Well, the Canadians already did it. Chris is Canadian. He did this. He's been able to interact in all of these amazing ways that don't require waivers.
Canadians, we don't cotton to your American space flight rules.
Yeah, us Americans don't all cotton to them either. So
no, I hope that the amazing outreach work that Chris has been doing will serve as a template for NASA's outreach in the future, because he has utterly nailed it. He has taken photographs, he has performed concerts, he has recorded music videos, he has made art and at the same time done outreach and sort of, he's a total inspiration.
And we've seen Don Pettit do amazing photography, and he is an American astronaut. But in general, it's the ties are so much more difficult. I know we talked to some of the Ure's Night people in a hangout earlier, and they were saying that the ISS people who send a video in to them actually had some issues because they hadn't gotten pre-approval to do this. So here you have these guys who have free time on the International Space Station using their free time to do EPO as civilians, and this is where I point out Astronomy Cast is not paid for using any U.S. federal dollars. We are strictly funded through your donations. Thank you. Please keep donating. So these guys, as individuals who just happen to be in orbit, did something for Ure's Night, and there's some explaining to be done. And that's just such a sad state for things to be in.
Yeah. So it's funny because I think NASA is going to be taking a lot of the credit for this outreach and stuff, but Chris Hadfield did this on his own. All of the stuff he's been doing, I really want to talk to him. I'm going to
well, it's all logoed with the Canadian Space Agency.
Yes.
So I don't think NASA can take credit for it.
I'll chase him down once he's back on Earth, and I'd love to talk to him about this stuff.
Yeah. No, it's one of these things where I wonder how many Congress people realize exactly what's getting lost with the sequestration rules.
Yeah. All right, cool. So let's record an episode of Astronomy Cast.
Okay, and let's make it a little bit more update than funding nightmares.
Yeah, a little more upbeat.
Yeah.
All right, if you want. I suspect this is going to somehow end with planets getting destroyed, though. So don't get so upbeat.
No planets die in this one. There's just a few rocks and ice balls.
Really?
Yeah.
At no point do migrating Jovian planets consume Earth-sized worlds?
No.
Promise?
Mm-hmm. Well, I can't promise, but as far as the models say, no.
All right. Or kick them out of their orbits into deep space?
As far as we know, that didn't happen.
All right. Yeah, but others... Anyway, don't worry. We're going to go there. We will make this sad and depressing. No problem. I'm all for it. Okay. I'm ready to press record.
I'm opening one more window. Hold on. Open all the windows. And we have one announcement, which is the reason I'm opening one more window, is because I don't remember what date the announcement corresponds to, because I'm a loser that way. I live by Google Calendar. Okay.
Oh, and I'm going to be at Google I/O starting on Wednesday. So if anyone's going to Google I/O, I'll see you there.
Okay. I'm now ready to press record.
Ready?
I'm mono. Okay. I've pressed record.
I have also pressed record.
It's even recording.
It is also recording for me. Okay?
Yep.
All right, let's do it. Astronomy Cast, episode 301 for Monday, April 8th, 2013. Planetary Migration. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great. Now, you have an announcement to make.
I do. As many of you may have heard, CosmoQuest, which is our citizen science virtual research facility for the public, is facing some financial crises brought on by U.S. sequestration, and we are trying to keep ourselves going into the future by asking for your help in exchange for our silliness. So Nicole Gallucci and I are orchestrating we're starting with 24 hours, but we may go out to 36-hour online hangout-a-thon, think Jerry Lewis telethon, except saving science, and using Google Hangouts because we lack money for mainstream television.
And the technology would rock that. It'll work.
Yeah, that's true. So we're going to do this starting 10 a.m. Central on July 15th, going into June 15th, going into June 16th. And we are going to start getting all of the events posted for that in the next couple of days. So if you're listening to this on the podcast, it should already be announced up on the CosmoQuest website. The more you donate, the longer we will stay online, bringing you science and bringing you silly.
Fantastic. I think I'll be making an appearance.
You will.
And many of our other friends, and we will get to watch you and Nicole go crazy over the course of 36 hours.
If we get enough money in, yeah.
Epic. All right. Cool. All right. Well, we'll have more information on the Astronomy Cast and CosmoQuest and all around. I'm sure we'll mention it in Universe Today. So, yeah. Cool. All right. Well, let's get on with the episode. So we're so familiar with the current configuration of the planets in the solar system, but did the planets always orbit in this way? Did they form further out and then migrate inward to their current positions? And what about other star systems out there? So this is actually one of those topics that's changed a little bit since we started recording Astronomy Cast. I think, with all of the discoveries of all these extrasolar planets, and especially these gigantic Jupiters that orbit so close into their parent stars, it's really sort of made astronomers puzzle out how are these systems getting into their configuration. So before sort of current ideas, what did astronomers think on how the planets got where they are?
Honestly, they pretty much said with the solar nebula model, things formed in situ, rocks to gas to ice. And it was just that simple.
So small particles of dust clumped together, and they got bigger and bigger, and just whichever gravity well this material could fall into, it formed a planet.
And that part of the story is still what we have. I mean, the solar nebula model hasn't been completely thrown out. It's matured from, you start with a disk of material and the sun's radiation dries out the inner part, things gravitationally clump together, they get bigger and bigger and clear their orbits, planet forms in place, to planet forms and may migrate over time. And this idea really started to come about when we found 51 Pegasus back in '98, because that was a hot Jupiter where no hot Jupiter belonged. And over the years, we had to try and figure out, well, how do planets migrate? And the model we'll be discussing today actually came out before our show. It came out in 2005, but it's really started to gain acceptance and gain prominence throughout the course of our recording. And Fraser and I often come across topics where Fraser's like, so let's talk about, and I'm like, no, not yet. It's not mature yet. Well, this is one of those topics that is matured and it's ready to be discussed.
I get very, very enthusiastic about the shiny new stuff, I will admit.
And it's kind of like wine. Sometimes you just have to wait.
You got to wait, let it age a little, wait a little more data to come in. So, okay, then I think you just sort of glossed over that, but that discovery of 51 Peg was amazing, right? I mean, so what is this object that they sort of discovered, and how was it surprising?
It's an object that's significantly larger than Jupiter, orbiting a star not too different from the Sun, but its orbit is smaller than Mercury's orbit. So when you start with a model of planets form, rocks near the Sun, gas giants out from the Sun, and then you find a gas giant on an orbit smaller than Mercury, that says something is very wrong with the picture you've mathematically painted.
Yeah, and so then they find this object and they're like, okay, so
Yeah.
now how does this work then? How did this get there? And so I guess that's when the investigation really started, was how did these things get to these places?
And that wasn't the only piece of data we had us confused. The other thing that we were dealing with was looking at the moon and other bodies throughout our solar system. It appeared that there was this ancient period in time when things were just getting hammered with rocks from space. It looked like for a brief period, the moon in particular was going through what is often referred to as a lunar catastrophe, where it was just this vast influx of objects from the outer solar system bombarding the inner solar system. We found evidence for this also happening on Mars, evidence for this also happening on Mercury, and it's a very brief window of just hundreds of millions of years, if that long. And so we needed to somehow figure out, how do you get this random isolated period in time when they cream the inner solar system for no particularly good reason.
Right, and I think, the formation of the moon itself could be considered a catastrophe, perhaps an Earth catastrophe when it actually happened. But I think what you're saying is that this period was actually quite short. So,
right, and when the moon formed, that was just one giant impact. The heavy bombardment, or the lunar catastrophe, this was object after object after object hurling into the inner solar system and just clobbering the surfaces of all the worlds.
And assuming if the moon was so badly beaten up, you can just imagine what must have happened to the Earth.
Yeah, we weren't entirely solid for a while there.
Right, just great big rocks splashing into molten magma, because the whole surface of the Earth was just kept in this liquid state from all this heat. Yeah, it must have just been not a place you'd want to live on.
Yeah, we weren't entirely liquid, but it wasn't pretty.
Yeah. And so what is the explanation for this late heavy bombardment then?
Well, what we're looking at now, and it explains actually both of these problems of how do you get planets to move and what caused the heavy bombardment, is what we're looking at is something called the Nice model. It's spelled like the word nice, but it's pronounced like the city in France, Nice. And this model says that when the solar system initially formed, we had Uranus and Neptune, maybe 10 or more astronomical units, 10 or more times the distance between the Earth or the Sun, closer to the Sun than they are now. We had Jupiter perhaps a little bit further out than where it is, Saturn further in from where it is. But over time, as they orbited, the icy bodies in the Kuiper Belt, which now is tenths of an Earth in amount of total mass, maybe it was tens, maybe it was hundreds of Earth masses worth of icy stuff early in the solar system. And as that material came tumbling into the inner solar system, it gravitationally interacted with these planets. And it interacted in such a way that the ice got hurled into the inner solar system, and the planets, slowly over time, most of them got moved outward. And as they moved, what ended up happening is Jupiter and Saturn ended up in this resonance, such that for every 2 times Jupiter went around, Saturn would go around once, and this would cause them to keep lining up over and over and over. And basically they pumped all of this gravitational energy into all of the stuff around them, and they sent rocks left and right careening into the inner solar system. They caused Uranus and Neptune to end up on highly elliptical orbits. Some computer models actually have Uranus and Neptune reversing location in the solar system.
I mean, we see Uranus is tilted over on its side, so something hit it.
Yeah, or torqued it.
Yeah.
So during what we think was probably just a brief period in the history of our solar system, everything got flung all over the place. And in this process, Jupiter came in, Saturn went out, Neptune and Uranus went way out, and rocks from space bombarded the inner solar system, depleting the Kuiper Belt of most of its mass.
And would that also explain where maybe the water on Earth might have come from?
Yes. So when we start trying to figure out volatiles, that's one of the sources of volatiles. And so we're looking at a solar system that's roughly 5.5 billion years old. And it looks like all of this happened at a period of roughly 3.8 billion years ago.
Wow.
Yeah.
Yeah.
So universe
And
humming along, solar system humming along, and sudden wham.
so how much of that then depends on there being Jupiter and Saturn working together? If there was just Jupiter or just Saturn, would we have had the same outcome?
Well, it's hard to tell what magnitude it would have been because we still had Neptune and Uranus. And depending on how they lined up over time, it could be that you ended up with a smaller version of this with two different worlds in resonance, causing all of this to happen through a different form of gravitational interaction. Now, both Uranus and Neptune are smaller than Saturn, so the effect would have been smaller. Um, and so it's hard without running the models to say just how bad it would have been, but there could have been something similar happening through a different form of resonance.
So Jupiter, good for the
Yes.
Earth or bad?
Early in the solar system, quite bad, but we got over it.
I mean, that's the question, right? Is it, gobbling up all of the debris in the solar system? And we talked about this last week, that it's still getting hit by a surprisingly large amount of material.
Right, and this is where good for the Earth or bad for the Earth, we do have to say, what period in time are you looking at? So it's like Jupiter has a bad boy past where it had to beat up the entire solar system for a while there. So when you had this resonance taking place, the gravitational interactions between Jupiter and Saturn, they grabbed all of the rocks that were at the time in Trojan orbits, these orbits that are in resonance with the Sun and Jupiter or the Sun and Saturn, flung those into the inner solar system. And then just the depleting of the Kuiper belt. So during that epoch in time, it's clear that having these four giant worlds in the outer solar system was really bad for the inner solar system, except for maybe the whole bringing water, but that could have happened in a less traumatic fashion. But over time, now as we look at it, yeah, it's clearly eating rocks periodically. And what we are still trying to figure out is it protecting us today, or is it potentially flinging things still? And we're not sure if it's gotten past its bad boy habits.
Now we look out into the universe, into the galaxy, and with the different, I mean, we've now seen more than 1,000 extrasolar planets. So what are astronomers starting to see with the other star systems out there?
So as we look at these hundreds of star systems, many of which have multiple planetary systems, what we're seeing is in young systems, we're finding the planetesimal disks, the disks of material that's still forming into planets that fits that solar nebula model that we had before. What we're finding as we look across more and more and more different solar systems is there is this overabundance of gas giants that are right snuggled up next to their host star. And occasionally we've caught evidence for what we think are stars that have eaten some of their inner planets. So where we're still left trying to sort things out is what starts the migration, what stops the inward migration, why is it that everything didn't fall into the sun, how is it that we ended up with these nice circular orbits? Well, we can answer that for our solar system. We think that over time the constant interactions with what's left in the asteroid belt and the Kuiper belt had the effect of taking Neptune and Uranus's orbits and circularizing them, and probably all of these interactions over time have worked to circularize most of the orbits in our solar system, except for poor Pluto.
Right. So is that sort of the trend that the planets want to go on through their gravitational interactions, and especially with all of these smaller objects, is to circularize their orbit?
Yeah, as long as there's other stuff out there to interact with, the larger bodies through all of these little tiny interactions, it all adds up over time to a tug that averages out to circular. So that's one of the neat things about having this distribution of debris is every single interaction is very small. But over time, all of these interactions add up to a massive effect that initially migrated the planets outward and then went on to circularize their orbits and stabilize our solar system into the configuration we have today. But there's still this mystery of, well, while things were migrating inwards, why did they stop? What was it about the distribution of material in our solar system that made things such that we don't have Jupiter in an orbit smaller than Mercury's, whereas in so many other solar systems we do see that. But we're also now finding rocky solar systems that look more like ours. So we still have a lot of really big question marks in our understanding.
Now, do we know if those stars, like the 51 Peg, are that hot Jupiter that's orbiting it? Do we know that hot planet is in a stable orbit, or is it possibly just spiraling inward and we're just catching it at a very terrifying time?
In some cases, it's pretty clear that we're catching them at a very special time. In a few cases, we found planets that have material getting sucked off of them, so they're getting basically gravitationally sucked dry, and they'll eventually spiral in and die rather badly. We see some planets that have tails from the material that's getting blasted off by the radiation pressure from the stars that they're orbiting. So there's lots of nasty things going on that are going to cause some of the planets that we see to eventually spiral into their doom. It's not a friendly galaxy. Getting stable solar systems isn't always straightforward.
So you mentioned that one of the big mysteries here is this idea that we don't really know why the planets stop this motion. Why do they settle into this final location? I mean, there must be some theories on this.
Well, people put forward ideas such as, well, some stars, perhaps they blast empty their innermost solar system, and the act of flinging material in that may happen through other solar systems' heavy bombardment doesn't fill in that particular area of the solar system, allowing things to keep getting interactions that cause them to spiral further and further in through various drag or other frictional effects. So here the idea is, if the star can blast out a region in the center, or planetary formation can clear out a region in the center, an outer planet doesn't have a reason to keep migrating. But if that doesn't happen, if the inner part of the solar system perhaps isn't able to form planets or doesn't get blasted free of material through the star's radiation pressure, maybe that gas giant, as it goes around, it's constantly interacting with the inner materials, and there's this drag-like effect where it keeps nomming the stuff and spiraling in further and further and further. So if you have an empty gap, that feeding process stops, migration inward stops. If you don't have that gap, it just keeps going in. That's one of the theories that people are working on. It's not finalized yet. We don't know enough yet.
Is it possible that that there were a lot more planets and a lot more material, and it did migrate just inward into its doom?
In our solar system, we don't think so. In our solar system, it seems like what we have makes sense. We can explain the mass of pretty much everything but the Kuiper belt. So while it's possible, there's no reason to believe that that's what happened, based on, we do see formations in terms of composition, in terms of chemistry, that make sense for things forming in specific parts of the solar system, and there not being a whole bunch of material that we can't account for that got eaten in the past.
Now, right now, I guess there's this migration that happens in the early days of the solar system, but there's probably other migration that's going to happen in the end of days in the solar system, as the sun bloats up into a red giant and, starts to give off material. It's going to sort of bring that whole cycle around again, right?
Well, here's where it starts to get interesting, is that's a slow and gradual process. So over time, the sun's continually losing mass. And as it loses mass, its gravitational pull on the rest of the planets is decreasing. This allows everything to slowly migrate outwards, but it's a constant effect. And there doesn't appear to be any trigger points in this effect that will cause a sudden change in the dynamics of the solar system. It looks like things will just expand out as the gravity changes. Where it gets interesting is where you have the sun's radiation pressure changing as it transitions from being the nice hot star that it is now to a much cooler but significantly brighter red giant star in the future. We're going to have the solar surface creep up pretty much on top of us. So it's going to be this interesting combination of the light is going to be right on top of us, blasting us, but the gravity from the sun, even though it's physically larger in radius, its gravitational pull will be less at that point because of the mass loss that has happened. We don't see any reason for anything bad to happen as a result of this other than clearly Mercury and Venus will be consumed.
Well, right. And I mean, will they? I mean, they'll be inside the atmosphere of the sun.
They will be eaten.
And there will be just so much drag that they'll just spiral inward at that point. And
I think it's more a matter of the sun's going to bloat out and just eat them. They're not going to have a choice.
But what will actually happen to them inside the sun?
It's hot and dense, and they will become happy little plasma lock of planets.
So, right, and they will just migrate right into the core because they'll be heavier, right? And they'll just sink into the core of the sun?
So the thing is, it doesn't quite work like that. So
please explain to me exactly how it does work. It's awesome.
The way to think of it is you're taking a rock and throwing it into a vat of boiling metals, boiling plasmas. That's not how you think of plasma, but it's so hot that rock is going to just turn into its component atoms rather quickly. Some of those component atoms are going to be light. They'll stay towards the surface. Some of the component atoms are heavy. Those may, depending on how they get mixed, sink somewhat. But I mean, our sun's atmosphere, it has titanium in it. Our sun's atmosphere, it has all sorts of other heavy metals in it that we see in the spectral line. So there's no reason to think that it's like throwing a rock into a pond. It's really more like throwing a glob of butter into boiling soup. The glob of butter starts out at a higher density than the soup, but it's not like it sinks to the bottom. It's more like it starts to sink and then becomes part of the boiling soup in the process.
So we'll just see this smear of Mercury in the atmosphere of the sun for a few rotations, and then it'll be one with the sun.
We're getting to see how this happens, actually, and we talked about this in the weekly space hangout last week, where we've observed some white dwarfs that are consuming planetary bits in their solar system. This is out in the Hyades cluster. And we can see in the compositions of the white dwarf atmospheres the remnants of these shredded, dead, no longer planet bits that used to exist and are now consumed. What we're now seeing with these white dwarfs, the signature of the planets in the atmosphere of the white dwarfs, is that sort of a signature that we may see when Mercury gets consumed. We'll be dead, but...
Right. Yeah.
Someone else will see in another solar system.
Right. And as we've said, astronomers are still on the fence. Will Earth be consumed? Will it be just scorched?
I think more and more of the evidence is piling up that mass loss will be significant enough for us to perhaps be safe. It's really a question, though, of just how big will the red giant be.
So I have one last sort of series of questions here, and this is about interactions between either in binary systems or other star systems that may come close or come, to us. Would these have any impact? Like, for example, when we first formed, we were in this solar nebula with a lot of other stars, and there was a certain amount of gravitational interaction between these objects. Would that have any impact on the planets that formed and perhaps how they migrated?
Well, when we first formed, luckily we seem to have been in a tight enough ball within this star forming region that we were fairly safe. We did form with this extensive Kuiper belt. There's the Oort cloud surrounding us, and while we have probably gone through periods where different external objects have influenced how many Kuiper belt objects or Oort cloud objects have been disturbed and flung into the inner solar system. it doesn't seem to have, with our solar system, affected the planets. Now, we do think that in other solar systems there are now rogue planets that have been stripped out of other solar systems and now wander somewhat lost between the stars. We seem to have just escaped that fate.
So far.
Luckily, stellar interactions are so rare that statistically it's unlikely that something of a significance to remove a planet would ever occur.
Yeah, I mean, even when we collide with Andromeda, chances are nothing's going to happen.
And what's kind of neat is I've seen people run mathematical computations on a black hole passing quickly through our solar system. And if a black hole passes quickly through our solar system, it may not wreak too much havoc. It all depends on the crossing times. So it's kind of neat to realize that it's actually really hard to destroy a solar system.
Is this the point where we plug Phil's book again? Death from the Skies. He's got a whole chapter just on a black hole moving through the solar system, and it's an awesome book.
Yeah, if it goes slowly, we're all toast. Luckily, right. Black holes are rare.
Yeah, exactly. But it would be the same as a very massive star moving slowly through our solar system. Also a very bad day. Yes. Cool. All right. Well, thank you very much, Pamela.
My pleasure. Thank you. Now, don't go away. We're just stopping our recording.
There was a lot of death and destruction in that episode, Pamela. There was.
It wasn't depressing death and destruction. We didn't destroy the Earth.
We just kept it in a mostly molten state for the better part of a billion years.
Yeah, I'm good with that.
Okay. Save. We are safe. All right, so stick around, and we'll answer some questions.
My phone was going insane the entire episode.
Yeah, my phone was ringing too. Hope everything's okay.
Just a lot of people forwarding this episode, so that's kind of cool.
Oh, good. Thank you, everybody, forwarding this episode. All right, I'm doing my upload right now. Okay, cool. Okay. All right, let's get some questions. Michael Jobin says the sun will be fluffy. Is that how we'll describe it? You're muted.
I hit the wrong button. I usually think of... I shouldn't be. Can you hear me now?
You're fine now.
Okay.
Yeah.
I usually think of fluffy as something that has lots of pockets of air in it, so I wouldn't describe the sun as fluffy, just lower density.
Right.
No whipping liquor.
I did an article about the biggest star, and the bigger they get, the cooler they get. Mm-hmm. And so, they get down to like 2,500 degrees, I think. It's 2,500 Kelvin, and very, very large at that point, and so very fluffy, but not fluffy.
Not fluffy from a whipped cream type of standard.
Yeah, exactly. Not a emulsion. Thomas Treneker asks, I wonder how you calculate resonance in orbits. So
it's just a matter of, does one planet's ability to orbit the star relative to background stars make a whole number division into another planet's orbital period. So if Saturn goes around every fictional 10 years for every Jupiter's fictional 5 years, that's a 1-to-2 resonance, because Jupiter goes around twice for every one time that Saturn goes around. It's just whole number integers. That's all it is.
But they're not in resonance anymore.
They're not. Now, what is cool is several of Jupiter's moons are in resonance, and this is actually what keeps Io so hot and Europa having a liquid sea.
Yes. Yeah. This is a good question. So Eric Charlin asks, Game of Thrones, what kind of system would give irregular seasons that last decades?
You know, I was reading that series of books, and the entire time I'm like, this makes no sense. That one really fundamentally bothers me. I don't know. We need more clues.
We don't see two stars, two
Yeah.
suns in the sky, because then if you could get this sort of situation where you've got two suns, you
Yeah,
know,
no, this would have to be some sort of a planetary tilt issue. Um, but how you get an irregular planetary tilt variation that people aren't discussing the change in the height of the sun above the horizon and things. It did just cause my brain to decide it needed to ignore that facet of the book.
what about an elliptical orbit and some kind of precession and a, fairly dramatic axial tilt all at the same time?
Yeah, that see, all of those things have observable characteristics that don't get discussed, and the fact that they don't
Yeah.
seem to have some way to know when spring or winter is coming, that just all leads
Yeah.
to me going either they're unobservant or this is a made-up fantasy world and I need to get over it and just read the book.
Well, the one of my favorite websites, IO9, actually did this. So they did an article about it. So it's 5 scientific explanations for Game of Thrones messed up seasons. And so one was a wobbly planetary tilt. One was an extremely elongated orbit. One was a complicated Milankovitch cycle. Oceans, currents, and tides, which I think is kind of interesting because you could, that we end up with pretty, we can end up with good and bad seasons, sometimes with just a, some of the way
El Nino and things
with
like
El Nino,
that.
La Nina, and even you can, volcanic eruptions on the other side of the Earth can end up causing you to have a summer, a year with no summer, right?
But again, all of these things, except for maybe the tides, would have major observables, and so that's where you notice how high the sun is above the horizon. You notice how long it takes for the sun to change its position. You notice the angular size of the sun in the sky, and you have a few very intelligent, very watchful characters. And over the whole history of it, with all their generations and generations of books, it's like, why didn't someone record hints? And so that's where you simply have to say, this is fiction, get over it, he's not Tolkien. Tolkien was actually very careful to make sure that his lunar phases made sense and his seasons with the stars made sense.
And his elves had pointy enough ears.
Yes.
Okay, let's see. What's Nicole Gallucci calls red giants fluffy, but she's a very big fan of all things flocculent. So,
I guess I'm hungry for meringue, and red dwarfs and red giants don't count.
So Graham Stickings says, I read a while ago that our system could still be considered chaotic and the planets could leave their current orbits. So, any opinion on that?
I haven't read that, and yeah, I would have to read that exact reference. The stuff that I've read leads to things are pretty much good right now because there's just not enough leftover mass to cause massive changes. The Kuiper belt went from probably hundreds of Earth's masses down to 1/10 of an Earth's mass as a result of the heavy bombardment. And we just don't have enough excess mass right now to cause the type of chaos that occurred at that point.
Eurasian Chica says, when you say it's not a friendly galaxy, does a spiral galaxy like ours treat our planets differently than an old red elliptical would?
Well, the thing to remember is an old red elliptical is basically what happens when a spiral gets hit the wrong way and has a bad day. So it's just a different age step in the process. A spiral galaxy like ours still has gas and dust. New stars can form. There's more supernovae. In the old elliptical galaxies, you're going to have fewer supernovae, which means one type of bad day doesn't exist. You're going to have less gas and dust. That leads to a less interesting sky, no nebulae. But but they're just an evolution of one another.
So I can't even describe the name on YouTube. 0xyzabcx0 notes that Chris Hadfield's video was actually based on a Reddit suggestion that Hadfield asked before launch. It's kind of cool.
Yeah, it
Somebody
really
said,
is.
"Hey, you should record a video on the space station." He's like, "Yeah, I'll do that." Like a boss. I think that's it. That's all the questions I've got. And as a follow-up, after doing a series of episodes on space stations, any plans to do an episode on series on space capsules, lunar planetary module, rover habitation modules? We actually recorded part 1 of a space capsule episode.
I think we did part 2
we
as
have never
well.
gotten around to part 2.
I thought we did Mercury and Gemini.
I don't think we've done whatever. We have not finished. We have left a series unfinished.
Yes.
For like hundreds of episodes, and we should come back to it. It haunts my dreams.
You have very strange dreams. Mine are haunted by much more interesting
Closure.
things.
I require closure. So at some point we will absolutely on the face saw that episode. We will absolutely finish the series on space capsules. Because we get emails.
Okay.
You're like, "Are you ever going to do the next part of that?" Yes, we will. Awesome. Okay, cool. Well, I think we're time to wrap it up.
Okay.
What's coming up?
Next up is Wednesday is Learning Space. We're going to have Jake Noel Storr from the Rochester Institute of Technology's Image Labs. And Thursday is the Planetary Society Hangout. Friday is the Weekly Space Hangout.
I won't be there for this one.
For any of you who are in the St. Louis region, I'm going to be at the National Science Teacher Association Expo. We will have a CosmoQuest booth set up, so if you're a school teacher in the region, come check it out. Come walk away with free stuff like buttons and stickers.
And then next Sunday will be our virtual star party. So
yep.
Yeah, it's going to be great. Okay, cool. Well, thank you very much, Pamela, and thanks everybody for watching, and we'll see you all. I guess you'll see people next on Wednesday.
Sounds great.
So here we are, Astronomy Cast, on time-ish.
Sorry for the delays. I was having all manner of computer chaos here.
Yeah. Hangouts are seeming surprisingly stable today. Last night it was crazy, but maybe we had like a lot of people. We had we had a full crowd last night. It was definitely a record on the virtual star party last night. We must have gone through 40 objects. It was wow. Like a mini Messier marathon. It was amazing. But it's like galaxy season, right? In the spring.
Yeah,
so
but it started at like 11 p.m. Central.
Yeah. Yes, well, 9 Pacific. It's no problem. It's good. Yeah, no, it's nice when we're in the wintertime and we start at 5 Pacific. That's a lot better.
Yeah, it was a little insane.
And if anyone has no idea what we're talking about, we do a virtual star party every Sunday night here on Google+. We hook up a bunch of telescopes. Oh, has Pamela crashed? No. She's crashed. Oh. Or have I crashed? Let's see. There's another Pamela.
It just like randomly redid the window.
Did you just refresh the window?
Yeah.
It's okay. I was entertaining the crowd.
Unexpected.
I was just mentioning Chris Hadfield's video.
Yes.
And you had something very poignant to say about that as it related to astronomy education and outreach.
Well, yeah, it was one of these things that while I was watching it, I realized this was something that had to have been planned in advance. This is something where he got help from Earth, and we actually had his son Evan left a comment, and there's a CDC radio interview that explains it more. So if you go to my Google Plus profile, you'll be able to find it. It's the most recent post. And looking at this right now with NASA, anything you do that isn't critical predefined that might be considered educational in nature, you have to get a waiver. And in general, anything that you want to get funding for, it has to be aligned with national educational standards. It has to be this, it has to be that. And so I don't think, given the current, this isn't a NASA problem, but this is rather a given the problems related to sequestration, which have also grounded some of the military acrobatics.
Which is our weekly podcast about space and astronomy, and we do it as a live Google Plus Hangout for some reason that we still haven't figured out. Practicing hanging out, I don't know. So you get to see it, warts and all, as we make all of our mistakes, and then it gets nicely edited for the actual podcast. So you get the sneak preview, I guess, is the point here. But you can ask questions, you can post comments, and we'll stick around after we do the show and answer your questions about space and astronomy. So by all means, stick around. So if you want, you can post a comment or question on the event page. You can, if you see it on my stream in Google+, you can post a comment there. If you want, you can use Twitter. Just use the hashtag Astronomy Cast, or you can post a comment over on YouTube, where the video is being I guess, originated. Did you see Chris Hadfield's video yesterday? To a live hangout and just share what we're seeing. So, no, it was great. We had, and Corey Schmitz sort of brought his new telescope setup, and it was just phenomenal. It was really
awesome.
Yeah, I want his telescope. He's got a Vixen 80mm refractor, and it was, but a really nice mount and huge wide field of view, and just phenomenal images he's pulling off of that.
Yeah, that's basically the scope I want. I just want the TeleView version of it, which is bazillion times more expensive.
Right. Where you choose car or telescope.
Yeah. Hey, I drive a 1998 Jeep Wrangler. No one can say I spend too much money on cars.
92 Volvo here.
You live on an island.
That's true. So if anyone has no idea what this is, what they're watching, this is a live recording of Astronomy Cast, which